introduce the team. We've got Isaac behind, doing the live stream here with us. We also have Nick on the computer. We've got Aaron over here on the lead programming. So he's running the machine. Tiffany's behind the camera. And yours truly, Jeff. I'm one of the sales reps for the area. So we're going to introduce our team. Our tool sponsor for the day is Allied Machine and Engineering. We greatly appreciate the partnership that we have. So I want to introduce, we have Kevin on the call and we have Jason.
Hi guys.
Hey everybody.
So we're gonna dive right into the demo overview. So what we're running today is we're running the Vortex IC and we're running the Gen 3 XT Pro. And with those, we're going to be going into 1018 mild steel and also T6 6061 aluminum. So right now we're going to have Aaron get the tools ready.
We'll talk about them.
Yep. So we'll talk about these here real quick, and then we'll do a machine overview. So right here we have the Vortex IC, and here you can see that they have the insertable carbides. And then Jason, if you want to go ahead and talk about those real quick.
Yeah, what you have there is the Vortex tool. What this tool utilizes is the same insert for the center and the outbound peripheral. We utilize the same insert there. The only thing we do is change the orientation between each location. What you're going to see off of that is two different chip forms. You're going to be real tight, conical, long, stringy, like a spiral noodle, if you will, coming off of the center. And your peripheral, we're kind of looking for short segmented spirals coming off of that.
Wonderful. And then on the Gen 3, what we have here.
Now, what you had before was an unbalanced tool. This one here is going to be a balanced cut. This one here works a little bit more off of a higher penetration, if you will. You're going to have a heavier feed rate. And with this, we're going to be spiral conicals, have a little bit of a tail to them. But in essence, the chip's going to be conical and it's going to flow out of the flute.
Wonderful. So I'm going to give these back to Aaron. I'm going to let him get those in there. And Tiffany, walk with me here. We're going to talk about the machine a little bit. We have the 2004 GRD high output. And what we mean by that is over 1,000 RPM, we've got about 18 horsepower to the spindle. Under 1,000 RPM, we're running up to 100 horsepower to the spindle, which is absolutely incredible. We also have the ability to do 1,200 inch per minute down the X and the Y travel. So that's incredible. So if you come down here as well, take a look what we have. We have the movable light curtains. So this kind of gives you the ability, as Aaron's working down here, to keep him safe and to keep us safe as the operators. You have the ability to have the machine running, have somebody come over and get the parts ready, use your overhead crane system, come on over, and then they'll be able to, load parts and unload parts. So it's absolutely wonderful to do that. On this machine that we have here today, it's 4,000 RPM, running up to about 400 foot-pounds of torque, which is absolutely incredible. We have the Cat 50 spindle on this machine as well. It has the capability of going to a Cat 40, but we really recommend that if you're going to be running, bigger tools and things of that nature, it also adds the rigidity of that, tool. You want to have as much rigidity as possible. So again, as Aaron's getting these tools put in, we're going to get ready for the demo, and we're going to be running the 1018 cold rolled mild steel and the T6 6061 aluminum, again, like we talked about. Aaron, are you ready to hit that?
Yeah, I think so.
All right. So we're going to send that machine down on the X to get started. Again, he's moving those light curtains to get it ready. Again, that pendulum mode that we're talking about is absolutely crucial for spindle uptime. A lot of people ask, well, who are we going after for this machine? The fabricators of the world that we're doing this machine for allows them to do their fabrication. It allows them to do, their bridge that gap between the structural and, the beams and the rounds that they have. So go ahead, Aaron, take it away. So again, this one we're running the 1018 mild, cold rolled mild steel. We're doing the Gen 3 XT Pro. And keep in mind, the unibody insert, this is perfect for high penetration, going straight in and out of material. So we're running at 400 surface feet per minute, 12 thou per revolution, roughly 17 horsepower. Crazy thing is we're doing 2,470 pounds of thrust and about 78.33 foot-pounds of torque to get those holes done. And you can see that it's relatively quick because it has the horsepower, the thrust, and everything, and the torque with that as well. So Aaron's going to take that out. We're going to take a look at that part. We're going to take a look at one of those. Thank you, sir. So then as we take a look at that, you can see the quality of the hole, the sides, and also the bottom. As Aaron goes ahead and sets up that aluminum for our Vortex demo, please keep in mind that your rake geometry, making sure you pick the right and the correct inserts for the material that you're going into, gosh, that is so incredibly crucial. And that's why we like to offer as an OEM, we have the ability to pair up with Allied Machine and Engineering and do this voucher program. I mean, it's phenomenal. Whether you've bought a machine or you're going to purchase the machine, let us help you get involved with the Allied team. I mean, both just for a live video, even through this crazy time, we have one of their application engineers, we have one of their field reps, and they're helping us through a live stream from their house. You know, that's phenomenal customer service. And, you know, to match our customer service where we want to help you, let us help you pick the right tools by getting to the experts faster. You know, they have people all over the country, you know, helping them and doing those things. So really, if you have any questions about that voucher, give us a call at 1-800-837-2503, or, you know, just go to the website, go to the contact us page, drop a link in there, and it gets to us, and just say you want to talk to somebody about that.
What are we running next?
So we're running next. What is the PSI on this machine? Can you handle a high pressure tank on this system? So 300 PSI is the max that we can handle on this machine. So as Aaron gets this ready, we will be running the Vortex IC drill into the T6 6061.
The 1018 steel.
Oh, sorry, we're still doing the steel.
Because we're not going that deep.
And what they're telling me right now is we're only doing 100 PSI because we're not going as deep into the hole as we possibly could with the drill that we have. So again, I apologize. We're doing the 1018 cold rolled mild steel now with the Vortex. So again, while he's getting this demo set up, it's crucial to understand the difference between the different drills that we're using today. The Vortex has the ability to really go into peak drilling. So on the peak, I'm going to grab another part here. When I say peak drilling, I'm talking about coming in right here, up here. And then when you're doing peak drilling, this could be at an incline, you're coming in here, and those inserts, the way the drill's set up, it's very crucial that if you're going to be doing things like peak drilling, pocket milling, you know, the fastest way to remove material is to use a drill. So go ahead, and even at an incline, this drill body has the ability to come in at an angle, do interrupted cuts.
Hey, remind us of the size of the drills. What are we running?
So, I'm sorry, I didn't even talk about that. We're running an 1 and 11/32 hole into this material. So I apologize, both drills today, the Vortex and the Gen 3, the Gen 3 XT Pro are going to be that 1 and 11/32. And again, are you ready? Are you ready to run?
Whenever you are.
Go ahead and hit it, let it rip. And then Isaac, if you can share the screen both with the GoPro and kind of throw up some of the control panel. Show the CNC control screen as well, just so they can see what's going on, you know, while Aaron's getting it set up in here. So again, some key notes while this is running. you really want to understand your machine. We have the ability with the high output to get 100 horsepower. Not every machine out there that you're going to use has that. So the Vortex really gives that ability to, really see lower horsepower machines still able to run larger holes, because you drop that feed rate and everything. And then on the Vortex here, we're running 1,706 RPM, 5.5 thou per revolution, roughly 11 horsepower, and you're getting close to 930 pounds of thrust on this one, and real close to 33 foot-pounds of torque on that. So, I mean, Kevin or Jason, if you have anything you want to add to those specs that I was mentioning.
Actually, I would like to add a couple things here on the Vortex after watching that drill demo. If you notice, when you ran the Gen 3, it was really quiet. You couldn't really hear it run. Big part of that is it's a balanced cut. It's a 2-flute effective tool. Here with the Vortex, we are a single effective. As Jason explained, we have a central insert and we have a periphery insert. So there is a little bit of an unbalance when it comes to an IC drill. So they tend to make a little bit more noise, especially in the softer materials like 1018. If we were running in, say, a 4150, you probably wouldn't get any noise at all. But in this 1018, you get into softer materials, this like stainlesses, you're going to get some noise out of them. The noise on this machine, you're hearing it a little bit more because the sides are open on a FlexCNC. So it's more of kind of like an open machine. It is guarded, but the noise comes out the side of the machine. So you do hear it a little bit more on that than you would on, say, maybe a fully enclosed machine. It's not a horrible noise. It's just that is a noise to be expected. I just want to point that out.
Really appreciate that. So on this 1018, we went all the way through instead of a blind hole.
Mm-hmm.
So you can see the quality on the sides. Really wonderful cut.
IC drills will typically give you a very nice finish too.
So we'll go ahead and we're going to get this one set up. Aaron's going to put the aluminum in there. So again, this is really crucial. Tiffany, follow me down here to this side. So on this side of the machine, whenever, we can have this 4th axis ready prep, and we can really get this going to where, you can do square, you can do tube, and really setting this up with a series of pneumatic clamps and everything. So we have another question here. Can you talk about why the Vortex works well for interrupted cuts and the sloped surface? Absolutely. So down here, I'll finish that up. We have the 4th axis prep ready on every machine that we sell now. Keep in mind that you'd have an indexable table so that way you could align to different size tubes. Go ahead, Tiffany, scroll out here with me. We'll go around Aaron here, and then we're going to talk about, I was going to show the pneumatic clamp, but we'll move the controller here. So if you took this piece of steel right here and you held it in your clamp and it was at an incline, what Deb's asking and referring to, when you're talking about an incline like this, and you take that peak drilling, that's truly done right here on this peak, and you come straight into that. The Vortex is a wonderful drill for that piece right there.
Hey, Jeff, do you want me to expand a little bit on why it can take that interrupted cut?
Absolutely, sir.
If you compare like the Gen 3 or even a TA to the Vortex,
Tiff, scroll out real quick.
You'll notice on the Gen 3 you've got a point angle on the front of a Gen 3. It's a 140-degree point. For that drill, it's pretty critical that the drill starts on center line on a relatively flat surface so that point hits first to keep the drill from kicking around. On the Vortex, the way the tool is designed, being a single effective, you don't have that point at the center of the drill. So the drill can enter with the outboard insert hitting first. It can enter with the center insert hitting first, and it's still going to cut a relatively nice hole. It's just the basic design of the tools is what creates the IC drill to be able to do interrupted cuts. You can do like the peak drilling there that he was talking about. You can move down the part, start on that slope. You can do a hole from solid and move over and drill a half hole out. So you could like drill out a pocket if you're, if you're needing to do a pocket in your part. Just various different options with the Vortex when it comes to interrupted cutting.
Yeah, and one thing you want to stress there.
What Kevin was saying here was this is the Gen 3 when you're looking and they're talking. This is the Gen 3 insert, and these are the Vortex inserts while they're explaining all of that.
Correct. Yeah. Yeah, and you can see the Gen 3 how it has that point. That's what's critical, that it gets started on a relatively flat surface. You have anything else to add, Jason? Or
yeah, one thing with the Vortex tool, when you are doing interrupted cuts or you're doing your plunge milling or anything like that, anytime you're in an interrupted cut for that duration, keep your feed. You want to cut it in half, but keep the speed you're saying constant. That's one thing that's going to help you save time. The other thing too, if you're doing your plunge milling, like you're saying with your slotting and everything, drill as many solid holes as you can, and then come back and then do your interrupted cut at half the feed rate, and that'll help save some time as well.
Yeah.
Wonderful. Thank you guys so much. Did anyone have any questions about the different inserts or anything? Please put those comments in there. We'll get them up as soon as we can.
Before we get into the aluminum, Jason and Kevin, if you want to touch base real quick on the different grades for the different types of materials, because I know we don't have the aluminum specific grades for these inserts. If you guys want to touch base on that real quick.
Yeah, I can talk about that for a little bit. With the Gen 3, what we're running right now is our P geometry. That's our steel geometry. That's what we ran in the 1018. We do have a cast iron specific geometry. We have a non-ferrous specific geometry for your aluminum, copper, brass, that kind of stuff. Since we're only doing 1 or 2 holes here, we're not going to take the time to change out inserts. We're just going to use our steel geometry in the aluminum. Basically, just as a quick demo. But if you're doing a lot of aluminum, obviously we would want to run our aluminum geometry. And then we have the same types of geometries for the Vortex. We have our steel geometries. We do have a high rake option, which is what we are running in the Vortex. We're running our M geometry. For softer materials, you run a high rake to help break the chip up. Then we also have cast iron and non-ferrous options for the Vortex.
No, so that's a great description. Is there a preferred step over amount for the plunge milling? That's what Fred was asking.
Not really. Those are pretty much determined by the application. Obviously, we want to have as much insert contact as we can. There's some times where, that overlap would be an issue, but most of the time it's all dependent upon the application, what type of slot we're trying to create. And a lot of times that determines how much the step is.
Perfect. Thank you. So Nick wanted me to show, we do a lot of demos. We do a lot of setups, and to prove that we're not trying to be tooling experts, we are the machine experts. We want to tell you what machine to buy, the width, the length, all of those things based on different parts. The gentlemen that we have on here with us, those are the smart guys behind it for the tooling. These inserts, to prove how important the inserts are, it just shows that if you don't pick the right geometry, the right letter, you can hear the chuckle in the background. It's very important, and we'd like to test everything. We like to push things to the limit. I'm sure if you've seen some of our marketing efforts.
Bad work holding, Jeff.
And this isn't not only were we pushing the limits of, the steel insert into aluminum, but we're also pushing the characteristics of our work holding as well. I mean, you take a look at what we have here from a lesson that we learned yesterday into today. We learned that you want to have as much holding strength as you can in the vise, wherever you're plunging that down. Because remember, keep in mind the thrust, the pounds of thrust that I was mentioning in the demos as they were running. You're talking 2,400 pounds of thrust that the Z is coming down into that part. If you don't have this piece held correctly, this is what, I mean, this is a great example of what happens to you. So keep that in mind. You know, we're no experts in tooling, but we are good with our machine. You know, so if you have any questions, again, please go to flexmachinetools.com, contact us, and there's a link for service. There's a link for, you know, inquiries, any questions you have that if we miss them in this live stream, please, please, please go there. What we have here again, Jason, what is the step over for the pocket drilling?
What that is after you drill the solid hole, if you would offset, say, like half the diameter. If you have a piece of 1018 there, you drilled originally with the 2 holes in it.
Yep.
Okay, if I were to slot that entire length of that, what I would do is I would come back in and drill another hole right in the middle of that. And then my step over would be to connect those two, half the feed rate. I would go ahead and cut those out and then come back in with an end mill to finish that out as for the slotting. That's going to save a lot of time, you know, manufacturing that slot.
Wonderful, James. Thank you so much for the question. Let's go ahead and send it. Let's go ahead and send it down. Go ahead and hit start. Let's roll this one. So again, we're running the T6 6160 aluminum. We'll be running the
the Vortex drill first.
We're running the Vortex here on this one. Keep in mind, with aluminum, you're able to run things a little faster. We're going to ramp this thing up to our max, roughly the max at 3,500 RPM, 6 thou per revolution, roughly 11 horsepower. Again, 480 pounds of thrust is what we're going to be doing. 17 foot-pounds of torque, roughly. So it's really incredible to see that stuff, you know, in play. And then again, Isaac, if you want to share the screen that Aaron's the controller getting that set up, it's crucial to see that, you know, the Omron and the Delta Tau that we have on the machine truly turned our machine from, you know, just a drilling machine into a vertical milling machine as well. With this ability, you got the infinite read on there, the look ahead. You have all of these features up here at the top. You've got the auto, MDI, the manual work offsets, and it's such an easy system to operate through. Again, we have, I don't know if anyone noticed throughout the demo that Aaron was running, there is a pendant hanging off of the machine, and we'll show that after we run the machine itself. But it's just so crucial to see how the machine operates. And go ahead, Aaron, if you're ready, center down. So again, right there, we're ramping up our spindle speed as we're taking it out to that 3,500 RPM. We want to make sure that we've got all that speed going into the material because there is that curve that the spindle takes to get up to speed. So go ahead, we're going to pop that part out, take a look at it. Tiff, if you want to come on down here. Thank you, sir. Beautiful. So if you take a look here with me, make sure we get that machine finish right there. There we go.
Looks like a nice finish.
So again, crucial that you have your work piece holding. Again, we will be doing live demos on work piece holding.
2 seconds.
So Nick just asked how long that took. Aaron's going to look that up on the screen. But again, it is so crucial to remember the people that we're selling this machine to and really focusing on, the fabricators. They aren't used to running a full vertical milling machine. So it's crucial to remember how important your work piece holding is. I'm going to give this piece back to Aaron. We're going to go ahead and put it back in. We're going to run the Gen 3 XT Pro now in the same piece. Again, keep in mind, we are testing limits here. We don't have the correct insert,
70 inches a minute.
but we're going to be running closer to 56 inch per minute. We changed that. So we're going to be running about 56 inch per minute, 16 thou per revolution, roughly 18 horsepower, and about 27 foot-pounds of torque. And again, quite a bit, you know, we're really pushing the limits here, and that's a good thing. That's what we want to show. We want to show the machine's capability. So actually, as Aaron's getting this set up here, again, talking about the capabilities of the machine, as we're traveling down, as Tiffany's rolling the camera down to us, again, keep in mind, we're on a 20-foot machine here, 4 feet wide. We have the ability to give you multiple machines in one machine, actually. And what I mean by that is these light curtains, you're able to set up your own work zone. And then outside of this, you have the ability to fixture onto the table. Hugo asked, could the Vortex being used on welding materials apply to rebuild heavy machinery in the welding process? Kevin or Jason, if you want to take that one.
Yeah, I can take it. There's going to be some things there that you need to really pay attention to because the Vortex will throw an exit disc. So if you have a stack plate or anything like that, you have to be mindful that that may not be the best thing to do. You have to make sure that disc is cleared out because that's going to be a relatively large chip that we're going to recut and it's going to damage the tool. Some other things to consider too, and when they say that, is that it's wide open. And that what do you mean by a weldment area? If you're anywhere close to that weld, you're gonna have varying materials. You're gonna have hot spots, hard spots. You know, things that's really going to change the characteristics of the material that you're drilling. So whenever you hit that at full speed, you know, it's going to cause chipping and things like that. However, of all the tools we offer, that would be one I would, you know, use in that application, but just go and know where I'm putting it at and what type of materials I'm going to be going through. You know, if you stay away from the weldment as much as possible because it's such a hard spot, but you know, that should very well be used.
Jason, and maybe you could answer Hugo's question with what other types of drills would you recommend in that instance? Since he asked, I mean, we might as well, if you can answer that today. What? Yeah, I mean,
again, yeah, of everything that we would offer, it would probably be Vortex to be one that I would lean towards.
Okay.
You know, but it's just going to be very application dependent, and you know where the location of that is and how close we are to the weld and things like that. We'd evaluate. I mean, there's some things that we may be able to do with like a TA or something, but you know, with the carbide and everything, if you put a side load to it, it's going to chip, it's going to shatter. You're not going to have a good result with it. So, you know, we may have to do some things differently in those type of applications.
Yeah, wonderful. Hugo, do me a huge favor. Go to flexmachinetools.com. Contact us. Or if you're comfortable sharing going to private, or send us your email address, we'll get you some more information and get you hooked up with the Allied team for sure. Please give us your contact information so we can we can dive into your application. We're going to go ahead and are you ready to send the machine, Aaron?
Yeah.
Wonderful. Go ahead. Let her rip. So next, while he's running that piece, I really want to bring home that ability to talk about the pendulum mode. So here, as he's running this down into the aluminum, again, keep in mind we're at 3,500 RPM, 16 thou, right through.
Works a lot better when the part doesn't move.
That's for sure.
Yes, it does work a lot better when the part doesn't move. Kevin was with us there the other day. He got to witness live some of our wonderful.
Yeah, we all have influence.
We're going to post that wonderful video of Aaron making sure that workpiece holding is crucial in the setup. So again,
hey, Jeff,
we'll take a look
quick,
at this one.
Didn't quite go deep enough.
Yep, go ahead.
Hey, Jeff, can I answer a couple of questions that have been popping up on the comments here?
Absolutely, let it rip.
Carl had a question about no chamfer being put on the part right now. Allied does offer, with the Gen 3, we offer some standards that are drill chamfer tools. We can make all kinds of specials, different lengths with chamfers. In our TA line of drills, we can put a chamfer ring on standard drills, or we can build, custom tools, to fit your application. So yes, we can put chamfers on the top of holes. We do that every day.
Kevin, I'm glad you mentioned that.
We're not doing it for this demo. Yeah. Here's a demo we did a couple weeks ago with one of our standard Gen 3 drill chamfer tools, where we were drilling through and chamfering at the same time.
So again, with that question, you can truly see what I mean by letting the Allied machine engineering team really look at your application. If you've tuned in today and you have questions about your work that you're trying to do, don't think because we didn't show it, they don't have it. They have the ability to do a lot of things that we're not showing today. So again, Isaac's got some B footage up there to show that piece that we're talking about, the chamfer drill.
We'll do a live demo of that drill.
So
Next.
So
a couple weeks.
In a couple weeks, we're really enjoying doing these live footage. We're going to be putting this plate onto the machine itself, and we're going to run that chamfer drill as well. But go ahead. I think I cut you off. I apologize.
Good. No, we were good. That's all I had to say about the chamfer. And then there was one other gentleman, I don't remember the name, asked about the largest size drill that we've ran on a FlexCNC. I don't know exactly what you guys have done, but I know when I've been involved, we have done it. I know we've done 2.5-inch holes on the FlexCNC.
Sure,
we may have done some larger. I know there's some customers out there that have done in that 2.5 to 2 5/8 diameter range on the FlexCNC.
Largest hole on the FlexCNC.
With an Allied drill.
With an Allied drill, we've actually run 3-inch holes. So
okay.
I mean that's incredible. And then we always ask the question, if you're trying to run even larger holes, it's not that the machine can't handle it. We ask, why are you trying to run, if it's just one hole, drill a smaller hole, interpolate that hole, and then, that way you're not having to always do high cost, expensive tools for a one hole operation.
Right.
But they have the capability of doing that. So don't discount the fact that Allied can or cannot, because the answer to that question is they can.
Right. And we also, where your interpolation is a good option for, just a few holes. Allied does offer other tooling that we can drill a smaller hole, and it's called our opening drill, where we can open up the hole bigger. And I would almost lay money we could put in a 4 or 5-inch hole on this machine, by drilling a smaller one and opening it up. So
we're going to share that challenge with Nick, later. We're going to try to put that to the test.
I'll bring in a tool for you.
There you have it. That's a few more weeks out after we get through the craziness. What we're going to do is we've answered quite a few questions. We're going to go ahead and send one more hole, and then we're gonna finish up with some questions and let her rip. So go ahead, Aaron, whenever you're ready.
Before you hit that, show pendulum mode quick.
I'm gonna move the light curtain. So we're gonna do we're gonna send this down, but we're also gonna, so Nick really wants, Tiff, if you want to swing around, Nick really wants to really show that pendulum mode, and this is crucial. It's crucial that go ahead. So it's crucial that you move your light curtains, because if you do not, your spindle will actually reduce in speed significantly to save a crash or whatever. So here, Tiffany, we're going to have to take a look here. So again, workpiece holding is crucial. Aaron's going to take that out. We're going to look at it, and then. So actually, we're going to come down here, just talk about some of the different things that we're doing. On the next live stream we've got on the 14th and the 15th, we're going to be doing a live demo 14th and 15th at 11 a.m. We're going to be doing flow drilling. We're going to be doing Allied drills again. We're also going to be doing our hex block here as well. We're going to be doing this. We're going to be doing this demo. Shows the dynamic milling of the machine capabilities. It's a wonderful thing where we can really show what we've got going on here in the flow drilling, the capabilities of the machine. And then there's going to be another live demo next week, next Friday, the 17th at 11 a.m. with Oh So Good OSG, another wonderful partner that we have. And we're so blessed to have so many wonderful partners that help us out with our live demos, the tooling and everything on that. Again, thank you so much for tuning in, for your time. We really appreciate it. Kevin, Jason, thank you so much. Guys, if you want to just say thank you and goodbye, we'll go ahead and sign off for today.
Okay. Thanks, guys. I appreciate you having us.
Yeah, thanks.
No problem. Thanks, guys.
This has been pretty fun, so appreciate it.
Anytime. We'll see you in the next one, everybody. Thanks so much for tuning in. We'll catch you later.